While we are still on the topic of solving solving polynomial equations, we are going to use a little technique that involves substitution, actually, and kind of reverting back to work that we had done in previous chapters. So this is going to look like example 645 and 646, actually. So we're going to cover both of these techniques kind of in one. We're going to do the factoring, and we're going to use the factoring to solve. So the first process comes here. We've got x to the fourth minus 8x squared plus 7 is equal to 0. If we're going to solve this using factoring, okay, solve by using factoring, what we want to do is a little bit of substitution. We're going to go ahead and say that a is equal to x squared. All right, so some number, you could use a, you could use b, you could use y, you could use z, it doesn't matter. The textbook that we use and the letter that I'm going to use here is a. So if I say a is equal to x squared, then a times a, or a squared, would be x to the fourth. So we can rewrite this as a squared minus 8a's plus 7 is equal to 0. Now, looking at this and trying to solve this equation, this probably looks a little bit complicated. But when I write this equation, you say, hey, we know how to solve quadratic equations. We've already done that back in chapter 5. So we're going to factor this just like we would in chapter 5. Factors of 7 that add up to negative 8 would be negative 7 and negative 1. All right, and we can solve those equations. What I like to do about here, though, is once we've got it factored, we can substitute that x squared back in. We pull it out for just a little bit to make the work a little bit easier for us to understand how the factoring process works when we're not dealing with squares, when we're dealing with x to the fourth power. This can be rewritten. If a is equal to x squared, then I technically here I've got x squared minus 7, and I've got x squared minus 1 is equal to 0. Now, again, using the zero product property, if this times this equals 0, then we can set each of these things equal to 0. You can factor this further. If you're supposed to completely factor it, which some of the exercises have you do, you could go ahead and finish factoring that. Factors of negative 1 that add up to 0 are going to be a positive 1 and a negative 1. All right, so if you have to completely factor it, then completely factor it. This one can't be factored, but we could solve this equation. So I've got this times this is equal to 0. That means I've got x squared minus 7 equals 0. I've got x plus 1 equals 0, and I've got x minus 1 equals 0. All right, so each of these equations is relatively easy to handle. Add 7 on both sides, take the plus or minus square root on both sides, and I get x is positive or negative 7. That's 2 of my 4 solutions. All right, positive radical 7 and negative radical 7. Here, subtract 1 on both sides. Here, add 1 on both sides. All right, so I have 2 solutions here, and I've got 2 more solutions here. Now, if you were just supposed to solve and you didn't have to factor all the way, you could have stopped right here and said x squared minus 1 equals 0, so x is equal to plus or minus 1. All right, or x squared equals 1. Take the square root, x equals positive 1 and negative 1. All right, so here are 4 solutions for our x to the fourth polynomial. Let's go ahead and look at something that might be a little bit more cumbersome, and I may have to kind of backtrack and erase some of my work, and that's okay if we need to do that. But again, we substitute a in place of the x squared. That lets us write a squared minus 8a plus 7, and this becomes something that's much easier to handle. This is an Algebra 1 question now at this point. But when we substitute the x squared back in, now we've got to do some of that Algebra 2. All right, so over here, I'm going to substitute a in place of x squared. So this is going to give me a squared plus 7a minus 18 is equal to 0. Notice how the constant is unaffected, the coefficients are unaffected. Factors of negative 18 that add up to positive 7 will be a positive 9 and a negative 2. Next, I substitute, and that's a plus 9. A plus 9, a minus 2. My a's and my 9's look the same, I apologize. Plug my x back in, my x squared in place of the a, x squared in place of the a, and now I can solve these two equations, all right? X squared plus 9 equals 0, x squared minus 2 equals 0. There's two of my roots, 3i, positive 3i and negative 3i. Over here, and x is equal to positive radical 2 and negative radical 2. Again, how you can factor some x to the fourth expressions. Now notice how I have 0 x's and I've got 0 x cubes. So if you have x to the fourth, x squared, and x to the 0, a constant, then we can use this method to try to solve by factoring. And so be aware that there are some approaches that are maybe non-conventional that you can take to solving these types of polynomial equations.